Chapter 9, Hypothesis Testing with two samples. On the Chapter 8, we worked on the hypothesis testing with only one sample, one populations. And for this chapter, we also working hypothesis testing. But this time, we do have two populations. And the first population parameter we'll be working on, that will be the proportion. So two independent population proportions. Let's look at this example, testing to the claim for two populations. In the 2009, in a survey of 400 college students, more than 85% of students who think Facebook is cool. So in the 2009, we do have the sample size 400 students. And then we do have the p-hat, the sample proportion, 85% of students who think Facebook is cool. Another year, 2013. This time, we do have the sample, 300 college students. And the sample proportion saying that more than 90% of students who think Facebook is cool. Can you conclude that the proportion of people who think Facebook is cool was greater than in 2013 than in 2009? And these questions, you can see they involve like two populations. First thing we need to do, we need to let which one is gonna be your population 1, which one is gonna be your population 2. I will let the P1 will be my population proportion in 2009. So I'm gonna change everything here. That will be the P1 hat and the N1. And then I will let P2 has the population proportion in 2013. Okay, so I will have a P hat 2 and then the N2 here. Now we do have two populations. So we want to compare the proportion of the people who think Facebook is cool was greater. Okay, so before that, we're gonna state the original claim. So they want to see greater in 2013 than in 2009. So 2013, that was my P2. 2009, that will be my P1. So I would say it's going to be P1 less than P2. Okay, we try to put the 1 on the left hand side. Okay, even though you can see this is going to be P2 greater than P1, but we try to write it like in order. And then that will be my alternate hypothesis because this is going to be strictly less than. So think about it. What is your null hypothesis? That will be greater than or equal to. Okay, right? So this is going to be left tail test. Okay, think about it. Some students may let the P1 will be your population proportion in 2013. Okay, just we change it this two. P1 will be the population proportion in 2013. And P2, that will be the population proportion in 2009. So my picture's gonna be looks like this. 2009, I do have a P2 hat 0.85 and 2, there'll be 400. 2013, that will become the first populations. It doesn't matter which one you call it like P1 or P2. However, if I let the P1 will be my 2013, P2 will be my 2009, then my original claim is going to be changed. So if I let it like this way, my original claim will become P1 greater than P2. Okay, P1 greater than P2. So this is going to be my alternate hypothesis. And then my null hypothesis, that will become less than or equal to. And we'll be working on the white tail test. It doesn't matter you choose the first one or the second one. You're going to get the same answer. You will have the same test statistic and same result when you interpret the p-value. But your original claim and the null and alternate hypothesis and the tail test will be different. So make sure on the chapter 9, first things you guys need to do, you're gonna state which one is your P1, which one is gonna be your P2. Okay, let's try to performing a hypothesis test for two proportions. Again, we'll be using the Z distribution. First step, we're gonna verify the conditions. Random samples. Both samples must be randomly selected from the populations. And then independent samples. Samples are independent of each other. Number 3, for each two samples, there are at least 10 success and 10 failures. Since we do have two populations, so we do have a p hat 1 and p hat 2 formula. Sometimes they may give you like the number of the success and also the sample size. So you may need to calculate the sample size by yourself. Number 3, for each of two samples, there are at least 10 success and 10 failures. So we do have two populations, right? And sometimes they may only give you the number of the success and the sample size. So you may need to calculate the sample proportion by yourself. Okay, this is how you guys calculate the P1 hat and the P2 hat. After that, you're gonna find it out if they do have at least 10 success and 10 failures for the population 1 and 10 success and 10 failures for the population 2. So that will be your step 1 in here. Okay, step 2, state the null and alternate hypothesis. I would recommend you guys try to state the original claim first, and then you could figure out your alternate hypothesis and the null hypothesis. But if you can handle it, you could just skip it about it. And then the null hypothesis, it can be equal or less than or equal to or greater than or equal to. An alternate hypothesis, not equal to, strictly greater than, and strictly less than. And keep in mind, null and alternate hypothesis, they are complementary. Okay, or you could think about it, they should be opposite of each other. Okay, and when you have a not equal to, you do have a two tail. Greater than, right tail. Less than, that would be left tail. Okay, step 3, compute the test statistic. This part, that will be a little bit complicated. Like you need to calculate the one called pool sample proportion, because this time we're involving like two populations. So we do have one called pool sample proportion. That will be x1 plus x2 over n1 plus n2. And then you could calculate the p1 hat and then the p2 hat. Then you could find the test statistic. Okay, the p1 hat minus the p2 hat over square root of, this is gonna be your pool sample. Pool sample times 1 minus pool sample, and then times 1 over n1 plus 1 over n2. Okay, that will be the test statistic. Okay, step 4, compute the p-value and interpret the p-value since we are using the Z distribution. So that will be using the normal CDF, lower value, upper value. And then p-value less than or equal to the significance level, that will be reject. Greater than, that will be fail to reject. Okay, state the conclusion. If you reject the null hypothesis, then you're gonna state there is sufficient evidence to support the original claim. You have to think about it, does it make sense when you draw the conclusion, okay? Or when you fail to reject, you're gonna state there is not sufficient evidence to support the alternate hypothesis. Okay, this is how you guys use your own calculator to check out your work. You could find the test statistic, you could find the p-value. Okay, let's work on the first example. In the year of 2002, The survey asked 1,343 employed people between the age 18 and 50 whether they use a computer in their work. And 916 say that they did. So this is gonna be your first populations, right? They do have the sample size, and I guess this is gonna be your number of success. And then second population, in the year 2008, they asked the same questions of an independent sample of 615 people. 465 say that they use a computer at work. Assume these are two random samples from the population of employed people. Can you conclude that the proportion of the people who use computer at work was greater in 2008 than in 2002? Use the significance level 0.05. So first, verify the condition. But before that, I need you guys to tell me which one is going to be your P1, which one is going to be your P2. So 2002 year first, so I'm going to let P1 will be the population proportion who used a computer in Word in 2002. So P2, that will be the population proportion in the 2008. Now, verify the condition. So, number one, random samples and independent. Number three, you need to check if they do have at least 10 success and 10 failure, right? So, in these questions, they didn't give you the sample proportion. They only give you the sample size and the number of success. So you guys need to use the formula to figure out what is your P hat 1 and what is your P hat 2. Okay, try, plug it in. Okay, check your work. So 916 divided by the sample size 1,343. You should get 0.682. And then P hat 2, you should get 0.756. Okay, now we're gonna check, do we have at least 10 success and 10 failures? Okay, I want you guys try pocket in. Okay, check your work. Okay, step 2, state the null and alternate hypothesis. First, we're gonna state the original claim. So the claim statement, that will be the last sentence here, right? Can you conclude that the proportion of the people who use a computer at work was greater in 2008 than in 2002? So that will be P1 less than P2 here, right? 2002 will be less than the 2008. And this is gonna be my alternate hypothesis. So null hypothesis, that will be opposite of this guy and left tail. Okay, compute the test statistic. So first, I need you guys find out what is the pool sample. Okay, add up the number of the success divided by total number of the sample size. So you're gonna get this. Okay, now find out the test statistic. Try, plug it in. Make sure when you guys input to your calculator, on the top, put the preference. Okay, and then divided by square root of the whole things here. Okay, you're gonna get negative 3.33. Okay, for the z here, I'm gonna put parenthesis 0.682 minus 0.756, close it. And then divided by square root. So second and then square root. So I have a 0.705 parenthesis 1 minus 0.705. Close it. Okay, and then another parenthesis. So 1 divided by 1343 plus 1 divided by 615, close parenthesis. Okay, enter. So I'm gonna get negative 3.33 here. Good. Okay, then compute the p-value and interpret the p-value. So we do have a left tail test, and then we find the test statistic, negative 3.33. So my picture is gonna be looks like this. Okay, left tail test statistic will be on this point. And my p-value will be the area of the left tail here. So how can you find the p-value? You'll be using the normal CDF lower value, which is gonna be negative 1e99. Upper value, that will be negative 3.33. Then you're gonna get these numbers. Okay, now let's try to use the calculator together. Second, VAS, number 2, normal CDF. I have a negative 1 second comma for the E99 and a negative 3.33. Make sure you're gonna use the negative, that's a below to the 3 here. And then go to the place, enter. So you're gonna see that will be so that will be 4.34, but that's a e to the negative 4. That's a scientific notation. Okay, so that will be 4.34 times 10 to the power of negative 4. And then you move the decimal space to the left. So 1, 2, 3, 4. So that will be equal to 0.0004, which just means that the p-value is really, really small here. When you have the small p-value, you will have a stronger evidence to reject the null hypothesis. Okay, now you compare with your significance level. This number is really small, so that will be less than or equal to 0.05, which is going to be reject the null hypothesis. Now draw the conclusion. So there is sufficient evidence support the claim that will be your claim statement. Okay, your alternate hypothesis here. We're gonna support that. Support the claim that Now we're gonna draw the conclusion. There is sufficient evidence to support the claim that the proportion of the workers between the age who used a computer at work was greater in 2008 than in 2002. Okay, so we have a reject the null hypothesis and we support the alternate hypothesis is true. Okay. Okay, we could use our calculator. Okay, let's try to do it together. Go to the stat, go to the test, and then we're gonna choose two population. Okay, two population, proportion, z distribution, hypothesis testing. Enter. And then we're gonna input those values. So x1, that will be 916, and 1, x2, and 2. And then we have less than. Okay, less than, that will be left tail, and then go to calculate. So first, we have the test statistic, negative 3.33. And the p-value, that will be 4.25 or 4.26 times 10 to the power of negative 4. That will be a little bit off from ours because the test statistic, we found it is like negative 3.33, but they found it like negative 3.34. Okay, so, but that's okay. It was really, really close to each other. And they also given the sample proportion. P1 0.68, 0.682, and 0.756. And then the pool sample will be 0.705. Okay, this is good. Okay, example 2. I want you guys try to do it by yourself. Make sure first step, you're gonna let the P1 and the P2. Okay, P1 and P2. So I'm gonna let population proportion for the white has a P1, and then P2 will be population proportion for the African Americans. And then now verify the conditions. So random sample, independent samples, and we're gonna get the 10 success and 10 failures. So try plug in here. Plug in x1, n1, x2, and n2. Find out the sample proportion. Okay, you're gonna get this. Check your work. And then okay, check this part also. We do have a 10 success and 10 failure. Okay, now state the null and alternate hypothesis. First, state the original claim. Okay, so they want to see if the proportion of the white iPhone owners greater than the proportion of African American iPhones owners. So you do have the P1 greater than P2. And that would be your alternate hypothesis. Right? So the null hypothesis, that will be opposite of this guy. And we'll be working on the white tail test. Okay, find the test statistic. Plug in those numbers. Find out the pool sample proportion. You're gonna get this 0.0933. Okay, test statistic. Plug into this formula. Okay, you're gonna get 2.36. Step 4. Compute the p-value and interpret the p-value. So we have the Whitetail test. Test statistic is 2.36. So p-value will be the area of the whitetail. And this is the z distribution. So that will be normal CDF 2.36 to 1E99. You should get 0.0091. Okay, compare with your significance level. That will be reject, right? Less than or equal to 0.05. So we're gonna draw the conclusion. There is sufficient evidence to support the claim that a large proportion of the white cell phone owners use iPhone than African Americans. You also can use your calculator to double check your work, your test statistic, and your p-value. That's it.